So let's continue. Else we're not making our time, and I don't want to keep you forever. Two things. First things first. How many of you know INSEA? Yeah, INSEA. INSEA. Okay. How many of you have a look had a look at INSEA lately? Oh, really? Okay. Well, you're committed. That's cool. I always need to be reminded to look at it. In any case, just wanted to bring attention to an announcement. I'll send an email as well to the entire mix. But the idea is, you guys, many of you, have just started your degree here. And I think it's time. You probably haven't seen much of us since then. It's just time for us to kind of get together with you and to ask you a few questions about, how things are going, what is good, what's not so good, what we can do better, but also some other issues that relate to the fact that the future of the MEX program may actually change. So, and to do that, the plan was to hold this meeting in 2 weeks from now, on the 15th of October, here after this very session. And I invite a wider range of students, also second years if they want, to actually talk about certain aspects. I'll send around a list for you guys to sign up. If you want to indicate attendance, so I can organize some refreshments or whatever else. We'll see what's possible. It depends, of course, on the availability and funding, but I think we should be able to organize some drinks or food and so on. But I think it's quite useful for you to show up because you can give some feedback, and we have a few things to talk about as well with respect to certain specializations. People want to take color specialization. Anyone here wants to do color? Okay. Excitement? Yeah, cool. Color specialization, cool. Yep. So it's worthwhile coming for you to come to talk to with Peter, because he will run it and he has some issues or some discussions regarding this, and selected other issues regarding the program. So that's the brief announcement. I sent another email properly around. Well, that is actually properly. That's the actual proper channel. But a reminder email so everyone is somewhat aware that this is going to happen. So if you want to see those kind of notifications in INSEA, there you can subscribe to different studies. No, in fact, you are subscribed to your respective study channels. In this case, it's Master of Computer Science, and then you see all the notifications that come out. Probably wouldn't hurt to even have an eye on this. I think you can set up an email notification as well. So even if you don't want to look at it, at least you get an email if something pops up. That's for you. Again, await another email. The idea is to hold it here, exactly in this room, because then I have everyone together, right, at the right place, the right time, and no big discussions, and we know how to get here. So that's that. Okay. In addition to this, we are tasked to do something else today. And that is every 2 weeks you get, of course, an additional session, which is often more a recap than it is something entirely novel, because most of you have actually had the background from your bachelor experience as software engineer, computer scientist, and so on, in different areas. And here in the Master of Applied Computer Science, the idea, or specifically in this course, the idea is to recap all that knowledge and bring it back together so we have a solid shared basis of understanding with respect to certain aspects. So last week I talked about software quality, so it's an interesting, diverse topic, I guess. So as with that one, bear in mind that all those topics should, in one way or another, find introduction to your product, right? You want to actually think about using this. And today we also already got a few examples of people that either are planning for or actually have implemented testing already. So the obvious case. So I think nowadays, if you develop a product, you definitely want to bear two things in mind, and one of them is of course testing, and the other thing is often security where necessary. But testing is really part of your skill set as a software developer. And there's no too little surprise, because most languages have either frameworks or literally have API capability that's built in nowadays, right? So it's no longer an appendix, an afterthought to a programming language, but a feature. Go is a good example for this one. Okay, talking about testing. Okay, when you think about testing, what comes to mind? What background do we have, please?
Testing the input or from the user, for example, testing some feature.
Yeah.
I don't know.
Yeah. Which forms of testing are you aware of? Cheating bit harder. Please. Yeah. Cool. Handwriting exercise. That stuff. One. What was the other one? Black box? Yeah. Yeah. Okay, cool. White box, black box. What is that about? White box testing and black box testing?
The black box is that you can know about the structure of the code and the testing code and the out code. The white box is like you know clear about the structure of the code.
Yeah. So how is that different? Well, you know, which one is better? Or worse? Or is there any better or worse?
I think all the next
Sorry.
that's not.
More important? Okay.
Why?
That's no question, even though I'm interacting with you, it's always an open question. Or why not? I mean, it's always.
Probably white box more in the beginning on your test module, for testing module, but then you want to include that into a good perspective. It's only black box. You really don't care how it does it or how each module works, as long as it's import or export various inputs.
Yeah. Yeah. So so it's a matter of scale, I guess, right? So what you're looking at, if you're looking at an entire system, maybe slightly different perspective than looking at individual models. Yeah, cool. Yeah. So you're just talking about the forms of testing for everyone who's late or early. Yeah. Other comments? What forms of testing are you? Is there anything else you want to bring in? We just talk about testing.
Unit testing.
That's good. Yeah. Any other forms of testing? Ah, right. This thing. Acceptance testing. When is that happening? Yeah. Yeah. Great. Yeah, I see your professional experience there. Yes, because it's important that the customer takes what you have provided in the end, right? So you're not just doing it for your own sake. Good. Other forms of testing. The more we do on the board, the less we do on the slide. So point is, because if you know everything, then there's no point of talking about it. And the fact, most of the important things are actually covered by you. Yeah. So that's one of them. Other comments? Aha, regression testing. What's that piece about? Good one. What's regression testing about? Right. So it's used. So when is it used? In the beginning of a project, or more towards the middle, or to the end? Yeah. I saw a hand reflex there. Yeah.
I think there is also a stress test.
Ah, okay. Yeah, that's right. Let's see if that's in my slides actually. Stress test, that's a good one. Yeah. What is that used for?
And it's like how many responses can the server how to say figure out, like sound at the same time for 1,000 or 6,000.
Yeah, exactly.
Yeah.
So
It's checking the I think the capability of the server.
right. Yeah, that's right. So right, especially in modern infrastructures where we have more cloud-based environments, we think about load balancing, scalability. Then it's important. That's a new dimension, right? So it's oftentimes less about the software, right? But as you mentioned, more about the infrastructure, right? Can it deal with a large number of requests and respond still efficiently, right? So and especially to withstand to some extent DDoS attacks, right? So good point. I think we'll hear more about this kind of test in a wider sense, hopefully in the security lecture that's going to be given by Basel at some stage in this course here as well. Cool. All right. Why is testing important? Boring question. Yeah, cool. Yep. That sounds good. What else?
Well, at certain points of development, if you have your development flow,
Yeah.
you can plan ahead and get like the word of issues early. I guess fix it early.
Yeah.
Instead of like you have analysis and you're not testing anything and it's like
Very good luck.
oh.
That's right. Yeah. Very good point.
And of course to catch bugs before they go into production.
Exactly, right? So you want to get your professionalism up and ensure that they're going into production, especially not if they're interacting with a different system, right? Because then it's incrementally harder to get that going. Cool. I think the motivation is something you have done for me. What is that? Anything that's particular about it? Unparticular about it? Notice anything? No in the United States? Any more context you see there? Night is good. We're getting somewhere. Yeah, cool. And everything is okay? Okay, cool. So we should invite two more geographers here. What? Ah, what is it? Yeah? Okay, what happened there? Time change or?
Blackout.
Ah, right. That's right. So this is a picture from the night sky from August 2003. So from a NASA satellite actually took this thing, and this is the United States, and there's a big of a hole there, right? I'm not talking about this one here, but of this one there, right? So, and if you look at it carefully, it's pretty much the whole northeast of the United States was basically out of power. All right, power grid outage was the Eastern Seaboard outage in 2003. Quite a big effect. Overall, in the US and Canada, around 60 million people without power for a few days. That's rare, right? I mean, in Norway, you can't do that. We only have 4, bad luck. But if you imagine, right? So that's certainly smaller in Norway, but still a considerable size. And with the high population density, outage can have massive impact. And again, this was a software error. Classical, a bug hasn't been caught. Several facilities were affected, and it was basically boiling down the to a software area that wasn't tested, that the grid interactivity wasn't tested. Quite simple issue, but it has led to several fatalities. Fatalities mostly not so much because there were suddenly people not seeing the light anymore and it could cause an accident, but rather if you have life support systems and so on, right? You always need to think a bit further than this, and usually we're just looking at the obvious one, the first order impact, but if you have an outage for 1 or more days, or usually for more than 24 hours, then it's becoming tricky for life support systems to maintain and function properly, especially if we think about hospitals and so on. So it was basically a race condition in General Electric's monitoring software that caused this entire outage. Quite an instructive example. So motivates the idea that this is quite important. So what's that thing? Ah, right, yes. Does anyone remember this? You guys are a bit younger. Right? It was a big deal in the 90s.
Correct. Yeah. So
It's a big deal again? Okay, so I bring it back up again. So in the 90s, there was a big discussion that we are losing the ozone layer of our Earth, right? And specifically above the Antarctica, basically, the density of ozone was very, very low. And whereas in Northern Europe, there was less of a problem. And there was a lot of discussion because this ozone has a particular feature of actually protecting of course, us from UV rays and therefore mitigating potential cancer, carcinoma developments, skin cancer, to break out and so on. And particularly in New Zealand, in Australia was a big deal, or it's still a relatively big deal, that people are much more susceptible to unattached skin cancer there. It was due to the ozone layer. And what you see here is basically depictions from a tool, the data analysis software, that was developed to actually analyze data. And the interesting thing here is not so much that, of course, somehow identified the black hole eventually. It was more the fact that the data that was collected was dated back to 1978, so quite a few years before it became a big issue in the mid-1980s. And the reason there was a matter of expectations. So they set up a monitoring system, monitored the whole globe, and wanted to figure out where the density of this ozone layer is particularly low. However, they had calibrated the system against data from the northern and southern hemisphere, but not the extreme poles. So it took them until 1985 to actually detect that there was a massive hole across above Antarctica, because the ranges at which they measured were not considering the fact that there was no ozone anymore. Right? So they expected a certain upper and lower boundary of ozone density, and everything left and right was completely discarded from data analysis. And only by ramping it down, actually considering that there may be places on the planet where the ozone layer is so destroyed that it's hardly measurable, was simply not considered in the analysis software. So another flaw, basically. And the reason there, or the consequence of this, was basically that it took pretty much 7 years. To actually figure out this hole, simply because the data analysis software didn't accommodate this. Again, a matter of building wrong assumptions, right? So those tested the wrong conditions against the wrong conditions. So one of the examples there. And the final example, what's that thing? Anyone know or want to know? It's also quite a nice example. Ah, right. No, the answer is not, but that's a good point. No, it's not. It's not an MIT system. I know what you mean. Yeah. So the idea was it was a system for radiation therapy for cancer patients. So treatment of cancer, targeted interventions. And the problem is people died frequently, too frequently using this thing. I think it's so it was fairly popular, and there were 6 cases at least of people dying from this by getting too high doses between 1985 to 87, and they received roughly 100 times the intended dose. So, right, so you need to set up the dose, and then you position it according to the position of the tumor, and then inject it and so on. And I think 3 fatalities, 6 people that affected, 3 fatalities. But the system got it wrong. It exposed the patients to 100 times the expected dose or prescribed dose anyway. And the thing was quite funny because it boiled down to getting the pressing the particular stroke sequence within 8 seconds. Right? So it was a very hard condition. So if you got a particular sequence of entries, everything was entered using kind of button-based input, keyword-based input, basically. And if you did this within 8 seconds, you initiated very race conditions that led the system to behave wrong, mistakenly, and of course incredibly hard to debug. Right, race conditions in the first place are incredibly hard to debug, but such odd constraints, right, that if you only do it within 8 seconds, then every issue. If you take 9 seconds, you'll be fine. Right. So that's a classic case where an automated test entry may not simply have picked it up because the sequence was entered too slow, and therefore never had occurred as part of the data. So again, another example where testing is super important, and of course, in this case, life-saving, right? So it would have been super crucial to get this right in the first place. Quite a challenging exercise there. So a lot of those examples are out there, and it's by no means new examples, really dated examples, but I think in all cases they show how important software is. You guys are not just developing software, you have responsibility. Right? If you develop software, it's good to find out bugs early, of course, but it's also important, but more important is to prevent it that they're still in there when the system goes live. And that was in all those cases that I reported here was basically the case that there were either wrong assumptions, expectations about the ozone layer, that there were untested conditions because they were just so incredibly complex, and that may have a rather local influence, in this case, 3 fatalities, or it may affect 60 million people. Right? You wouldn't know, and you may also not know, because once your software is deployed on a modern cloud-based system and so on, you wouldn't know how many customers you probably have, right? Right, so your code may actually become famous in a wider sense, or be absorbed in a richer ecosystem of software and suddenly be used as a module or the like. And you better want to get that right, because living with this kind of burden is probably not the best of ideas. And the outcome, or one of the key insights from all those problems, was that there was a lack of independent code review. So basically, everyone who had actually reviewed their code were the developers themselves, right? So they came with their wrong assumptions or same assumptions and actually reviewed their own code. So it's probably not the most clever of ideas. So, and I think we have learned quite a bit from this in our professionalism, that we encourage you to review your own code critically. Another aspect was that a lot of the software, especially in the 80s, 90s, was simply taken from older devices. Right? They didn't rewrite it. They just took the old stuff and, changed some bells and whistles or some details to actually fudge it into a new system, and just continued using it, right? Especially in the medical area, there are horrific stories about software development. I think Richard can, I don't know, there are those insulin pumps that are of, are actually not independently vetted at all, but they just seem to work well most of the time. Therefore, it should be okay all of the time, right? But again, in a medical context, that's not something you want to take your bet on. All right. So testing, what's about, quite straightforward. Here we have a bug, surprise, surprise. And it's all about ensuring the system does what it's supposed to do. As mentioned just in the beginning, it executes without errors, in particular that it indicates problems gracefully. It's not wrong to have problems. It's not wrong to receive errors. It's just important to catch them. That's what tests are about, right? To early figure out that there are issues in the program, right? So the idea is not necessarily to testing can't be comprehensive of software. Software is notoriously affected by bugs, but the point of tests is to minimize potential bugs in the system, because it will show the presence of them. And every time you discover a new bug, it means, well, you probably didn't write enough tests, or should write another test against it. So this specific bug should never occur again, right? So it's kind of a lesson we learn, especially when we do software development. So you guys talked about different test types already. So I just go a bit ahead here. It's really depending on the perspective you assume in terms of the software development cycle, but also in terms of your role in the software development project that define what kind of test you're actually using, right? So we have different types that depend on perspective. Sometimes it's just by testing by review. You just review code directly. Very common in an extreme programming context where you pretty much review code immediately, or maybe you code together. And then we talked about black box and white box testing. We learned more about this. And then the different levels and stages of which different forms of testing are applied, right? So unit testing, integration system testing, acceptance testing, you mentioned regression testing. And then there's the testing of non-functional features, right? Which comes into performance testing in particular, and stress testing. So in this slide, it's really more to figure out, okay, does the system meet specified system requirements, as opposed to does it particularly, are there any visual functional bugs in the system? When you guys probably know this problem here with software development, did anyone see this before? Standard, everyone saw it, good. Who didn't see it? In any case, it's a typical example, but it shows the divergence of different interpretations for a given problem, right? So whatever the customer actually explains is, of course, ambiguous. Customers are not necessarily geniuses at getting their message conveyed, right? That's why you're dealing with product owners. You need to debug it. You need to go away, talk about what they actually gave you a specification, and come back to them. Is that what you actually mean? So that's one of the issues. Then there's, of course, the design, which may be overcomplicated, often the case. How it's sold by the business consultant, of course, more luxurious. How it's priced, how the documentation is next to non-documentation. That's probably the most instructive one because I think we find this quite often. And billing and what the customer probably wants. Right? So it's kind of this divergence discussion there. So that's the importance of testing there, testing in this context, because the customer oftentimes doesn't really know what they want themselves, and they most certainly don't have any idea about testing anyway. Right? They just say, oh yeah, you need to test the system. Well, good luck, right? Which of those tests do you apply, when, and so on, all that kind of magic. So it's not that easy in the case. But to get it somewhat going and then to structure our thoughts a bit, and that's the purpose of this session. It's really more about getting a clear understanding of the different types of tests and organizing them systematically. I want to bring on two terms, the idea of verification and validation, because they don't only apply to the context of software development, but of course more generally into scientific methods. So we'll see that again, and it will have a different meaning in that context. But it's fairly relatable if we talk about it in this particular software development. So who wants to get a crack at it and say what's verification versus validation in the context of testing? No one? Sorry?
I have to go back to
Yeah. Who wants to give it a crack? Go at it, and then we'll figure it out. Verification and validation. What's the difference? Yeah, please.
Verification would be where you verify that the code works or what the intended purpose.
Yeah.
And the validation was that you how useful it was trained.
Okay. Yeah, I think you're onto something. So basically, it's pretty much what you're saying, right? So the verification is simply reduced to the term, are we building a product right? It's assessment as to whether whatever you build is built to specification. Right? What are the requirements? What is set out? What did we build? How can we verify that this is the same? This is representing the functionality that was required, and of course the non-functional requirements that were set out. Quite straightforward. Are we building the product right? Whereas the validation, as you say, puts the customer perspective on, and actually says, well, are we building the right product, right, in the first place, right? You may just have a wrong specification, right, of a product that does not take into account some real-world concerns that the customer knows but is unable to explicate, right? So that they don't articulate it properly, and so you don't take it into account. So there's those two different perspectives that need to be borne in mind. So it's not just you as a developer may often concentrate on the first one of verification, but he told me to do it this way, or she told me to do it this way, so I did, and now I'm good and I want my money. But it's actually not useful in the real world, right? Because the customer got it wrong as well. And of course, you could try to insist on your money, but in the end, you didn't make the customer happy, right? Because your job should have been as well to dig deeper and figure out, okay, what's the actual purpose of this product, right? Going one step further in the interface and think, okay, what is the customer actually using this tool for? And does it make sense to use this specification? Should I poke deeper and challenge the customer? Hey, are you really sure you want this as part of your product? So that's the key idea there. And there are different techniques, of course, for doing this, to abuse. I mean, of course, the idea of having some sort of review to assess it, but of course, the testing perspective is quite essential, different forms of testing. And classically, there's a differentiation between those three types of testing or reviews, if you like. The initial one would be basically involving having some sort of visual inspection of the code. So you look at the code and the design as it was set out and agreed upon, to identify problems. And that usually brings in your past experience. I mean, if you have been actively involved in code reviews, you bring a lot of your baggage with you. For example, if someone else is coding in Node.js and you had a background in this, and even you don't know the actual product they're producing, and you frankly may not even care, but you are doing the review, you would spot issues in the implementation, right? Based on your code experience. For example, in any other context, or in the context of switch statement, did you provide a default, or did you externalize string into constants, for example, those kind of concerns. And this can then, of course, be opened up not only to include coders, but probably also other stakeholders, right? The quality assurance team from the customer that may not write the code, but just wants to be involved in assessing whether your code actually holds up to their requirements, to their specification standards, and so on, right? So that's one of the concerns. So it's very important to discuss this as well. Generally, the target of this is to work on code quality. First of all, of course, to mitigate potential problems before they appear. So you're looking at code. It's just a inspection. But more importantly, to actually understand the code well and ensure that you know what's going on. Because you may have made the experience that if you even use the same programming language, but you have 2 different peoples or 3 different peoples working the same piece of code, you'll be surprised how divergent the standards and notations that individuals use can be, right, in terms of commenting and so on. I'm not sure, have you guys experienced that in your group settings? That, people have totally different conventions, right? So assuming you guys converge on, we need to use Java as code. Well, one person may write the code in the conventional Oracle specification. The other person may commit to Google specification for Java code, or someone may write in C++ notation, de facto, right? So, and commenting equally. So it's really 2 things. On the one hand, you agree on the tech. On the other hand, you also want to agree on certain standards with respect to code quality and documenting and so on. And of course, it doesn't only extend to the code itself, but also documentation of the code, right? What tools do we use to, for example, highlight and discuss APIs? What language do we use to describe comments? So some people choose, for example, to use active terms to describe methods, and incomplete sentences, and others rather favor very complete specification as part of each method signature and so on. So it's different types and different standards that people adhere to. The other aspect is to look at the different process and minimize cost. And cost is, of course, a very abstract term here. It's, of course, the direct cost caused by potential issues that are detected too late, but also the cost in terms of your mental effort. So if you constantly need to bend your mind to understand someone else's specification, it's really, really tedious and really, effortful. And there's a certain resistance because you always fall back into your own ways of thinking. So you're more worried or more concerned with actually reading the stuff than actually being productive and doing critical review. So it's quite important to do that. I think if you haven't done so, that one aspect that you could consider discussing in your group would be, okay, if we code in this particular language, what's the standards we're using? Right? And they're openly provided. So if you go to Google and you want to code Java, there's a Java spec for Google developers that is literally out there, which is different from the one for Oracle developers and so on. So anyway, so that's the obvious one. The next one is functional testing. So you mentioned before, okay, functional testing is important. The system is basically a black box. So we don't have any structural insight. We don't know what's happening inside, but we just know the inputs and outputs and know what we expect. Right? We intentionally avoid testing it with any structural insight. Why is that good? Why shouldn't we just have, I mean, we always argue for transparency, inspectability and so on. But why is it important to be aware and being able to perform black box Yeah. You're absolutely right. So cognitive load is what you're saying, right? So you can't keep an overview anymore. So the risk is there that you stop paying attention, right? So because it's too much simply, you're kind of outside of your working ability as a human to deal with the complexity. So you just trust, hopefully this whole thing works, right? But you're actually not long critical, assessing different tests. That's right. Yeah. What could be another aspect? So that's a good point. Very good point. Do we always apply a greenfield approach when we're doing development? Do we always start from scratch? Who thinks yes? Do we always start from scratch? When we're developing software?
Just saying.
Yeah, he said yes. Okay, one against. What does the other say? Who thinks no? Right, one person no. Okay, that's odd representation. The rest is asleep. Okay, what are you thinking?
So regard to you're thinking about existing components and modules.
Exactly.
Which you haven't built yourself.
Exactly. Right. So that's most of the time the problem there. So if you're in an industrial setting, and especially if you work for a company, or even consulting for a customer in particular, most likely you will not have the freedom to start from scratch. You may not even have freedom to choose your tech, right? In fact, you may be employed because you know a certain tech for that particular company because they don't want to necessarily retrain, right? So in all those cases, you kind of buy into an existing system. And that may mean you use someone else's system if you're relying on third-party tools and build on top of it, or you may simply rely on work that has been done by someone else with different conventions and different thinking and so on. Perhaps it's a programming language if it's linked using, for example, web standards and interaction and so on. And sometimes you simply won't know the insight because it's proprietary, right? In the worst case, the source code is lost, then you really have no clue anymore what the heck is going on, right? So if you're interacting, for example, with Windows components, Microsoft components by default, you would assume that they're proprietary, you have no insight, and that's roughly it where you're testing it. So you need to have knowledge or ability to test those systems without knowing anything else but the functional output that you would expect for a given input, right? So that's the kind of minimum requirement you have. And then it's quite straightforward. You put some data in, expect a certain output. If it doesn't come out, well, the component is busted, right? So you need to think about it. Do I replace this? Do I put effort into inspecting it or to get access into the insight and so on? So relatively straightforward, but foremost it actually minimizes the cognitive load. That's the most important aspect associated with it. So basically you're testing against the specification that you lay out anyway, right? So if you think about an interface in development, you have an interface that says, well, if you call this method, the following should happen, right? Who cares what the implementation would be? And that's roughly the idea there. So it fosters two various aspects. Of course, what we mentioned right now, you can work with existing software, but it's also fairly robust against changes in existing systems. So the implementation on component level is more like change than the system in its entirety. Right? So an individual component can be exchanged, the implementation can be modified and so on. And black box testing would be robust against this, right? Because the overall system specification, that was your point, doesn't really change. So it's quite helpful there. And it also means it fosters concurrent operations. So if you have a test team and you have a development team, they could in principle write tests and implementation independently. Right? Because if the input and output is well known and actually specified and testable, well, the testers can go ahead and wait for you to write write the actual implementation eventually. If you conversely rely on the knowledge of the internals of the system, right? You need to know details about the implementation. Then, of course, you lose this ability to separate those two activities. So, how do you write good black box tests? One aspect, of course, to say, well, we test everything. Is that exhaustive testing? That's always a way out. But imagine you have input type. What does exhaustive testing mean in this context? Trying out all integer conditions? That'll keep your system going quite a bit, and after a few hours, the boss would come and wonder why your tests run so long, right? So your regression test would be a bit overbearing, right? So in practice, exhaustion is often not a really good idea. So we need to use a bit more of our brain. But the starting point is there, basically looking at the specifications. And one of the classical approaches to test equivalence partitioning. So if you find a specification that says the system should do the following. So, for example, if a person is under 16-year-old, the system should prevent the person from voting. If the person is older than 16, then voting is allowed, hypothetical, whatever. So if the specification sets out that this is the primary role of this particular component, well, you have something to start with, right? Because you can identify boundary values. In this case, the year of 16 or whatever else, right? So the idea is then to basically cover your basis by exploring all the different partitions that sit there. In a very primitive example, it's simply being younger than 16 years, perhaps exactly 16 years if you like, and older than 16 years. So you have, well, technically two partitions that you want to really test in this particular case. So similar example, right? You have a very straightforward example. You have a situation where an instructor can enter student marks and so on, and there's a range between 0 and 100 for the marks. So that's roughly how your master thesis will look like, right? So 0 or 100. That's it. Between we throw a dice. But what are the partitions? How many partitions do we have? So sad, everyone's sleeping. Apart from one, please.
So, directly you would have 0, you would try 100, you would try 101, you would try 101, and probably a couple of moves.
Yeah. So how many partitions do we have? If we look at boundary values. Okay. Any other values? Any other values? I'm just collecting. So no. You see my poker face. I don't have one. Anyone else? Who goes for 5? Who goes? Ah, right, yeah, but this is not part of the spec, right? No, you're right. The mapping to the marks, that's a different. Yeah, that would be interesting. Actually, it's a nice variation. I'll do that next time. So we can do it, yeah. But okay, 3 or 5. So what's the call? Who thinks it's 3 partitions? By looking at the spec. Who thinks it's 5? Who thinks it's 27? Okay, just doing a sanity check. So Richard, you're undecided, right? I'm undecided. So the idea here is literally to apply sanity within the specification. And the specification just gives you 2 data points, right? It just literally gives you 0 and 100, right? So technically, there should be no difference, behavioral difference between the range between 0 and 100, right? So whatever you enter, you enter. But the tricky bit is what happens if you enter 101 or -1, basically, right? So that's the idea. Within this specification, it would be just 3 partitions, basically, right? So you just test those 3 boundaries. So what would happen if we then had our fancy Norwegian marking scheme from A to F? How many partitions? I need to figure it out for myself first before I make this stupid comment.
No more likely, possibly.
Yeah, that's probably right. Yeah, I agree. So 8 partitions, right? In this particular case, I want to get this right. Are there any challenges with respect to partitions? No, the cutoffs are clear.
Try randomize numbers. You try randomize one, you try 101, then you try a random group between 0 and 100. Would that be any difference?
It would de facto not be any difference, you're right. It would not be any difference, but of course the outcome, basically the output, right, that you test against may be slightly different, right? So for example, if you enter a mark between 0 and 100, right, there may basically may just return the value you have entered, right? So your testing, your test, if you randomize it, would need to accommodate the fact that the output deterministically changes, right? So if you put 51 in, well, you get 51 out, right? Whereas if you next time you put 64 in, you get 64 out as a mark, right? So the test would need to accommodate this. Other than that, randomization would in principle work. But for such a system, I think you want to have some sort of deterministic randomness. So you would do random calls, but with a predefined seed, so it's kind of reproducible. Because one of the risks you have is that suddenly you have an error and you can't recall the actual input value that has been chosen.
But if you part of the test would be to actually say, now I'm trying this input.
Yeah.
And then you send an input, then you expect a different response, and then you either say that it's successful or that it's failed.
Yeah. That's right. That's precisely right. That's the idea. We want to automate this. So your example that you're describing is actually a problem, a big problem. And that is if you have a larger number space or interaction between multiple parameters. Right? Here's super simple. We put one thing in, and which is the student mark and so on, and get something out. If you want to, for example, correlate student marks with age of a student, I'm just making stuff up, right? So you want to identify whether older students generally get better marks or worse marks, right? Because they're more mature, more diligent workers, such as this class here, right? Or are the bachelor students more productive for whatever reason, right? Who knows? If you want to figure that out. This is really hard because suddenly you have two factors that interact, right? And orthogonally, right? So in those cases, so your question is very good actually. You suddenly have this, well, de facto continuous two-dimensional space, right? So if you assume that the input vectors are continuous. So what you do then there, if you want to test those kind of cases, well, there are several techniques. One of them would be purely random. They call it kind of a Monte Carlo simulation, where you basically combine randomly the inputs and see that it roughly produces the right output, right? Random systematically. And then there's the other approach. The problem is with randomness, if your sample is too big, right? Too many age groups and too many things, and you need to actually have a large number of tests to run to cover your space somewhat, right? To be kind of ensure that you actually covered everything sufficiently. The alternative is to partition it in a so-called hypercube. Hang on, I need to get this right. It needs to be, yeah, right. Symmetric hypercube, where you say basically, okay, random value for this section, random value for this section, random value for this intersection, random value for this intersection, right? So this way you can get, because the risk if you perform pure randomness is that, the random tests may all be in this area. Right? That's still random because your number of tests may simply not have been large enough, or you don't have enough time, or it's too expensive to run. Especially run simulations, that's much more involved generally, because they run about large number of rounds, and that's the risk that you get. You say, well, yeah, simulation makes sense, right? I tested it, I sampled it in randomly, but it may just well be that you only sampled a subset of the parameter space, that because you didn't control it. Here, you would say you combine randomness with structure. It's kind of with a supervised approach where you say, well, grid within, 0 to 10 and in terms of mark, and 0 to 10 in terms of age, right? We test randomly in here. Then we take 10 to 20 in terms of marks and so on, and 0 to 10 in terms of age. So that's the next grid and so on, and random value here. So this is one way of ensuring that you cover your parameter space more comprehensively. So that's, yeah, it's getting messy. Fundamentally the same idea, right? You just need to think about multiple dimensions then, and so on, right? You can imagine if you have a third dimension, then it becomes, your pure randomness will just not hold anymore, right? No. So then you need to really structure. So your point is absolutely valid, right? So that's the simplest case, simple one dimension, straightforward, 3 partitions, but just to think about it. But this is one attack point you could take, right? You look at the spec and see, okay, what's in there? Can I make sense of this, and how can I sample this? And of course, it depends on the parameter types. If you have integer, it's very straightforward. You can actually test 100 values. That will not be an issue. If you have a float, you're kind of already in the probabilistic region, right? Because there's no way you can actually sensibly exhaust the parameter space in testing, right? So we agree on this. Any questions regarding this? I may have just lost people. Does anyone follow the idea? Or no is a valid answer. Test-driven development needs to Say it first. Someone needs to say no. Didn't. Okay. All right. Okay. Humor at 2 o'clock in the afternoon is not a good idea. Noted. Note to self. The other thing. Yeah. What's the other thing? We had the. What other tests did we have? We talked about black box tests. We talked about. What's that? What? All right, we get there as well. Yeah. You like the non-functional thing. So that was functional. You are right. You actually took a different pathway than I expected everyone to take. But we come back to this one. What is another testing we do before that? Ah, finally. That should be the one. All right. So what's the other term for white box testing? It's another term for it. So what was black box testing? What was the term that was on the screen? Function. So what's the other one? Not quite. There you go. So that's yeah. For realistic, you're kind of hitting the same spot. Yeah, structural testing. Well, correct. Structural testing, right? It's different in that. How is it different? Who's faster? Don't know. Yeah. Opposing views? The opposing views, of course.
So, following the example of the grading,
Yeah.
let's say that you have a function that is supposed to calculate the average for the grades. Then you actually verify it or check that all inputs generate the actual output that you want.
Mm-hmm.
And you get that in the function.
Mm-hmm. Okay. That's yeah. I see where you're coming from, but this you could still do it with black box testing, right? It would be slightly more generous in terms of selecting your input parameters and partitions. I'm more getting on your comment with respect to comprehensiveness, right, of white box. So so there's two perspectives you can entertain, right? On the one hand, yes, of course, by assuming structural or knowing about the key thing is you know about the content of the black box, right? You know how code is actually written, like you literally know the code, right? You know how that teacher entry system here you would know how this is actually implemented. You would see the code, right? You would see the branches, right? The if statements, the else statements, and all that kind of stuff. So with this knowledge, the idea would be that, of course, you can have much more comprehensive tests, but on the other hand, that kind of challenges the ability to actually stay on the high level, right? And not look at all the intricacies. Plus, if that little box changes, you're kind of screwed because your tests will all fall over, right? So the idea is to separate it from two perspectives. So on the one hand, it's more comprehensive but more local. So that's the key idea. The idea is they are taking the student example from just before. Unfortunately, I should have written this out as a code. If you imagine you get a method that not only allows you to enter a particular student mark, but also does checks for specific combinations of marks, which is not explicitly stated. No, assuming you use an untyped language, right? So, and you're entering basically a string in a field where you expect an integer, right? This would be something that would be easier caught by white box testing as potentially, because it doesn't look at the specification what's supposed to be in as an input, but it looks how the system handles potential unintended inputs, right? So instead of entering 51, because that's the mark you actually give the student, you enter it as a string, for example, 51 written out or whatever else. And this is kind of the exercise where white box testing can come into play because if you detect a test in your code that, for example, tests for a given type, right, in the method, so it's not really functional, but structured in the sense that it actually looks, oh, is the input type an integer as opposed to a string, that's the kind of test you write against with that knowledge that, there's a test for different types, let's try random other types and see what the system explodes, right? You bring this knowledge. Alternative 2 is you know the code throws an exception. Well, you may want to produce this exception to be called, actually, right? You may want to produce a condition under which an exception is called, because any calling code will rely on this exception to some extent, right? Because it needs to be propagated up, even if you have an invalid number format or whatever else. That's all the kind of stuff you may not necessarily know from a black box perspective, but that's something you definitely know from a white box perspective, because the implementer has decided to implement it a certain way. And that's the idea there. So you literally look at the if and else statements, how it's implemented, and see if you can break those ones, right? Independent of the external requirement. So you no longer look at the external interface, you actually look at, is there something that could break? Is there a switch statement that I could, somehow violate in one way or another? Even though there's never an explicit mention about, switching, because you could also, switch statement could be used in alternative to an if-else conditional statement, for example, right? And they have different properties and different requirements. So if you, for example, forget the default statement and a switch statement, you may simply not capture a particular case, which is off, whereas in an if-else structure, you would always capture that, right? Because the terminating else would capture it. And you can't know those things in the context of black box testing, but in white box testing, it's very obvious. So you need to go into the nitty-gritty. So it's comprehensive, yes, but generally micro level, right? Because it's very, very dependent on the insight, your knowledge of the code. So, yeah. So it's basically whereas strong your internals. Is to actually test each decision point, right? Each conditional branch and so on should be run through and should be actually tested. From a black box perspective, you have no clue what your code coverage inside that method is. From a white box approach, you need to cover all pathways in order to ensure that your program is measured. And that's the measure and test coverage that comes to play. You need to have some sort of insight, of course, of the structural internals of code. So every time you have test coverage, it assumes pretty much that you have a white box approach. Okay, what do we use? White box or black box? Which one is better? And why do we have both? Which one is better?
I think with black box, you have a choice.
Yeah, pragmatic. Yeah, you're taking the practitioner route, basically saying, yeah, well, come on, I can't see the inside internals anyway. I take what I get, right? Plus, I didn't develop this thing. I just need to ensure it kind of works for my purpose, right? So that it looks like my product is broken, but it's actually I can figure out hang on, on my dependency developed by X, Y, Z. It's actually broken. So right, so it's also liability, mitigating liability. Right. So that's well too. Yeah, if you find yourself in DLL or jar hell or whatever else, so that may be well. Yeah. Other point. Well, okay. If you look at this debate, right? So this kind of takeaway you can think about it. Primarily, problems are defined from a customer perspective, right? So it's kind of representing the real world to some extent. So customers can be wrong, but they are interested in interface to the real world. Can you stuff be used in the real world setting, right? So as a developer, we kind of build a model of that, right? So that's the specification interface stuff, right? So you get actually what does the code need to do, what quality metrics do you assign to it, all that stuff we kind of briefly talked about 2 weeks ago. Where you break it down into what other characteristics I need to meet. So it becomes this code, if you develop an information system, it becomes somewhat a model of the real world. Yeah, a student management system that manages marks, assignments, and so on is not the real world. It's a representation, abstraction of the real world, focused on marking in particular. Right? And here's the thing: there's a bias by developers that, of course, come in, and that may be reflected in the implementation, right? From a customer perspective, the implementation may not be the same as it is from a developer perspective. And if we tie together the idea of validation and verification, we can see it in a way that the customer is primarily interested in the implementation from the outside. Does it do what I want it to do, right? I put a mark in, I get the mark out. That's roughly it. I don't know about branches. I don't know about code coverage. I don't know about structural integrity. I don't know about C++ or Java or Node.js or Python or whatever else you want to use to do it, right? So I can't be bothered. Whereas developers kind of more think like this, right? You know the code. Oh yeah, I need to test, for my switch statement. Oh, did I do this right? Right? Or is the dependency correct? We're kind of more on this side all the time. And that's where risks, but the opportunities come in. But if you link it back to the idea of validation and verification, it suggests, well, you kind of need to be both, right? Where sensible. If you're developing a nitty-gritty module, right, that you want to deliver in a larger project, clearly here, right? Because you get explicit specs, you build, you test against your own stuff. But when it's actually time to integrate it, it's more on this side. Then we need to do black box testing. So someone else will invoke your module that you thoroughly tested using white box testing, verified against some sort of spec, to see whether it actually corresponds and actually has value in the real world. Does it solve a business problem it's supposed to be solved? Does it serve entry of student marks in the student management system, right? Or is it just, yeah, it processes integers when I want to, right? It's able to, I can run a get function on it and return the integers again. Whether that represents student numbers or anything else doesn't matter from the developer point of view. It's just data types and data structures. Here it's real world knowledge, right? So hence the kind of idea. So white box testing actually corresponds more to a kind of verification perspective. Did I do something right? Whereas the validation perspective, bring it back to the real world, is somewhat on the black box side. This is a loose association because it can, if you get the specifications wrong, then black box testing won't help you much further. But that's the idea, that you can roughly structure those two dimensions by perspective that we have on code. It can be very different. That's why we do the exercise in product owner and implementing team and so on. Please.
Because I wrote down verification as building the product, right? And validation as building the right product.
Yeah. So the right product is kind of here. I mean, it's a loose association. I can see your point to some extent, but the.
No, sorry, sorry.
That's good to assess. Anytime you get those weird kind of box things, it's always good to debug it because we get stuff wrong all the time. But literally, the validation is like the thing about validation. Every time you read this, think about it always means something related to the real world. Always. Yeah. In science as well. So in science, it's if you design an experiment, you have some sort of research question that you're researching, right? So you know, is smoking after midnight more unhealthy than smoking before midnight, right? So just have a very sensible and realistic example of a research question you can do, right? So you design your research question, and the question is then, on the one hand, you have the implementation. How do you design actually, how to assess whether people smoke before and after midnight? Well, if you rely, for example, saying, okay, well, every time you smoke before midnight, you kind of need to, use this app and indicate this in the app, right? The question is there, will people that smoke, for example, after midnight have their phone around to actually indicate in the app that they smoke? That's the real world magic. Does it actually make sense that people follow this kind of protocol for this particular real world setting, right? From a verification point of view, experimental design, it kind of makes sense. Yeah, cool. Well, basically, I want to assess this. We'll get some feedback from the potential participant, right? But does it match the real world conditions for people do that, right? So, or another even better example, smoking while driving, right? Would people, while they're driving, actually use the app to indicate, oh, I've been smoking while driving? So, so this would flaw your entire experimental design because it doesn't correspond to real world conditions. Because they would get a fine if they were to participate in your experiment, right? There could be an issue. So it's always about validation. Does it actually make sense? But this is kind of the validation in a weaker sense, but in a stronger sense is also, do your findings that you actually arrive at the end with make sense in the real world? Do you have something else that backs that up? Right? Does anyone else have the same kind of thing? It's a bit of an odd example, I guess. I need to work on this. But the idea is basically, it always links to, does it make sense in the real world? This one, does it make sense to the implementer? And that can be a researcher or the developer. All right. So, questions? Any more questions regarding this? You don't need to know it by heart. It's just building a bridge between those two worlds and realizing they belong together to some extent. Slightly different purpose, but it depends on the worldview sometimes. Slides will be uploaded anyway, so you can debug your way through them. This one is straightforward. You guys are acquainted with this. I mean, all those waterfall models we have thrown around in classes, throughout your bachelor years. I'm sure you're pretty sick of it, but yet another one. Come on. Are you still with us? Somewhat? Yeah, okay. I would be asleep as well. So, I don't blame you. So, levels of testing, right? The idea is that in progress of developing tools, software, and so on, it's not only about how abstract an individual component is, you know, how much insight you have, how much knowledge you have, but also the system grows over time, right? That's the main problem. You mentioned that before, right? So we're shifting from a more micro-level internal focus perspective to a more macro-level system perspective where things get bigger, right? And that's precisely it, right? So we have the unit testing that you guys are mostly acquainted with if you have a developer background, right? Because you're thinking, well, okay, let's test this method, right? Let's test this feature and whatever else. Those are organized by units that model some sort of, you know, entity in the real world. And then we have to make a subsystem out of it, you know. I mean, if you think about information systems, there would be a different subsystem could be a logistics system, material management system, HR system, and accounting system, whatever else, right? It's a system. They kind of need to be integrated, so that at this stage you're moving a level up. You're giving up on the you're giving the structural characteristics are given up. It's just whether to enter subsystems is a whole kind of work, right? So if I send, for example, the invoice into the accounting system, does it actually arrive there and produce an invoice as an output? How it's done, I have no clue anymore because I can't. The system's too big for me as one developer or tester. And I want to look at it from a real world problem. Does it solve a real world problem? I don't care how you implement it, right? So that's the kind of level here. So it's really getting much more coarse-grained by actually collapsing those individual units into modules, into systems. Again, the 4 examples that I brought up here, into a coherent system at the end. And you mentioned acceptance testing at the end, right? So this is, for me as a developer, if I do iterations on individual systems, I'm refining the HR system. Question is, does it still work with the entire, you know, the entire other modules and so on, that still work together, right? In the end, when you then decide, okay, I'm there, I'm done, I want to get, you know, done with this, here's then when the user comes in, right? Where you have some sort of user testing, where the user, ideally in the company, in the setting, and with the future users are actually used to test, play with the system, see whether it makes sense. And this will be the condition for acceptance, meaning they, you have fulfilled the contractual requirements, you probably get the right? That is not possible. But that's the idea. Generally, the end goal is getting acceptance testing, getting the signature, and then off you go next to the next project, right? Hopefully, we can hopefully that agree, but generally that's the idea, right? So this is about progression. I think you guys have seen that a million times. You're probably very, very acquainted with this. With unit testing, we work at individual executable units. It's generally on the developer side. Structural and functional behavior should be guaranteed. So again, we have both test types that are potentially involved there. Then we have integration testing. Slide set is a bit off here, whatever. 2 characteristics about integration testing. It's basically about more or less thinking about API level tests. You have different units that are united by an API, think REST API or the like, and you want to ensure that the functionality of the combined units makes sense, right? That they satisfy a certain set of requirements, but you can't always do that. If you are sitting in the middle and testing on the system or you kind of may know how the APIs look like, but the implementation may not necessarily be done, right? So, and if you want to test those specifications in isolation, it's not always that you can assume that everything that started, with nitty-gritty modules, unit tests, has been done from the get-go. But if you want to continue, basically, you sometimes need to substitute certain elements of the system, and this is generally, depending where you sit, and this is generally characterized as stubs and drivers. Did you guys hear about this elsewhere? Yeah? No? No or yes? If yes, I'll jump over it. If no, I'll go through it. If you want to bypass it, say yes, and I'll bypass it, even though you don't know. Huh? Okay, just to be so. Just teasing you guys a bit. So the idea is, systems are developed in levels, right? So we have, for example, we have layer 1, 2, and 3 in the system. And the idea there is that you may have a certain so if you come back to our little assuming, for example, yeah, that's right. Assuming you have a UI now, and many of you have the situation, right? You have an UI ready. You can put something in there, right? You can put some entry in there, but many of you may not have yet finished your database that actually stores the content, right? How do you test the UI independently, right? How do you know it's actually doing what it's supposed to do? Or in this very simple student management system example I just brought up before, where you basically enter the mark, how do you know it's actually doing what's supposed to do on the UI level? Well, you develop some sort of stubs that kind of give a dummy response to every input you give. So, for example, if you have a REST API and you're sending your student information to that API, a stub would be something, a mock API that would just blindly return 200 status code in HTTP. Basically, yeah, successfully stored, done. But wouldn't do anything. So no functionality, just emulate a successful or successless response, right? A 404, for example, or 500, or whatever you want, or 401, depending on what you test. So the stubs are basically dumb entities that emulate the lower levels that you want to interact with, right? So think UI, developing UI, but you didn't do your REST service yet. Well, then you do a very, very, very crude REST service that you want to interact with and have just standard responses for each request you get. Always the same, right? Even you enter a different student number, it would always return the same student. Those are stuff. Quite straightforward. But this is a nice way of actually isolating testing. So if you are working on UI and you couldn't deal, no one has dealt with the database yet, you as a UI tester can nevertheless already start testing your stuff and say, yep, if I put the certain stuff in, and I tick all the fields, or I forgot to, for example, tick the box for birth date or whatever else, I get an error and all that kind of test that you want to test on the UI level, but you don't actually care how it's managed on the database level, then you can actually perform this test already by simply stubbing the database, right? That's the idea. Depending on the complexity, this can vary. So conversely, you can have the other way around. So if you're starting from the you may not necessarily start from the UI, but actually from the bottom. So you may have a you have, for example, in the database, right? So only the data structures that you want to, for example, emulate, or implement and so on and store and expect, but you haven't implemented the UI yet. Right? The UI is not available. But then you need to emulate the test in a way that I can simulate user behavior. For example, by entering a student, one of the marks in a student management system, you need to write some sort of driver that actually injects something into your system so you can spit some return value out, right? You need to emulate as if there was a user interface interacting with me. This may imply, having a, it can be as simple as things like curl calling performing a REST call, REST injection HTTP call, on your database, for example, or on your API to trigger certain behaviors, right? This would then be a driver, but actually this driver in reality would be an implemented component, such as a UI performing the request when you press the submit button or something like that, like a web form or the like. If you don't have it, you need to emulate it. That's where the drivers come in. So it's the other way around, right? So you can have two perspectives. So sometimes you emulate the bottom component, sometimes you emulate the top component. Drivers, the idea is there that there's an emulation of the top component, right? Something that the user probably needs to do, but can't do yet, and because the system is not there, but inject something into something that you have implemented, and conversely, the other way around, that the UI is actually implemented, but something that it's interacting with is not implemented yet, so then this needs to be substituted or stuffed. That's the idea. Does that make sense somewhat? Right, and if you have REST API, you want to test it from both sides, you just need to figure out, okay, which party is there and which party is not there yet, and that may just be a driver or stuff. I mean, it sounds more complicated than it is. You kind of need to emulate different depending on the perspective you want to take, right? So the idea is you can test UIs, of course, without the lower level middleware or sort of other implementation, and the other way around. Bottom up and top down integration. Testing. Okay, well, now that's hopefully getting quick, yeah? So system testing is relatively straightforward. You set up the entire overall system and run this whole thing. The challenge is pretty much more on the northeasty drift side, I guess, more on the operations side. That means you actually deploy this whole thing and actually run it. And one of the challenges here is often that you may actually, for the first time, not run it on your hardware, but on your customer's hardware. So that's where things can fall over. Simple things. Richard may have some stories about that. But next week. Yeah. Right. Next week you have some interesting stories about your real-world experiences. But that's where the deployment comes to place, right? How to make it convenient? How can we automate it? How can we ensure the whole system works, right? That's where you iterate over, getting that stuff done, right? Fixing your Docker files or whatever else, right? That kind of So it's really more on the inside of the system. Of course, is there an overall behavior that's desirable, but it's still tested generally with you, meaning you as a developer or your development team and so on, before the customer comes to play. So once this is kind of settled, you think, yeah, it kind of works under a customer system. Let's give it a go and roll it out and let them play with this. Only then you involve them, because you don't want, ideally you don't want feedback from testing, or you don't want your customer to figure out really embarrassing bugs when you put your system together finally, right? So you kind of want to get this right and only then move to acceptance testing. And that's where you see or don't see money to some extent. Important thing is it needs to be together with the customer. So in fact, the acceptance test then also really is close to life, in that it actually uses also user data. So not only user system, but it's definitely around the target environment, but also involves user data in addition to that one. So okay, right, that's a bit of testing there. Sounds good. And we are at 3 already. I take way too long, do I? Unbelievable. That's right. So we'll not push that too far. I just wanted to lose 1 or 2 words on. This is actually from Android, but I think it's quite instructive. I just want to highlight some of the key things. That's the number of tests. Right? How do you distribute your tests? Where do they exist? And in reality, it's really like probably 70 to 80% of all tests sit on the unit test level, right? So and it becomes increasingly less. So you may have on the integration level or testing system level, not integration level. So we integrate, for example, APIs, REST APIs. It's a much smaller fraction of tests that actually sit there and operate there. And UI tests very, very limited relative to the number of overall tests. So it's important. It's not like that throughout the entire stage of this waterfall testing model that you have an equal amount of effort in writing tests. It's kind of the case over time if you do your job well. Because if you catch most of the issues in unit tests, then the integration tests will be, hopefully smooth and may require an iteration. And going back and kind of fixing it up within a particular module before passing a particular test, right? But generally, you would expect to catch bugs early, as Johanna mentioned earlier. So therefore, you don't need to deal with this at a later stage. That's one of the key ideas there. Most of this kind of discussion of theory is taught in Somerville, right? Who doesn't know that book? Who had to read this book? One person? Who doesn't remember what they had to read in that? So the same. But in the end, it's about the knowledge, right? You know what you need to know. So all the different testing, different stages, different perspectives we have, and so on. It's just one of those standard things they always pull out. But there are other works that talk about this as well, of course. But it's just good for you to be aware what kind of testing you are doing. Is there an opportunity to change my testing perspective? Do I, and so on. So do I actually do white box testing? Do I need it? Perhaps it's not really necessary at all. So that's quite valuable. If you want to learn more about testing, it's also worthwhile looking at Google testing. They're actually quite cool in terms of practical advice. A bit geared towards Android, I think, but in general, there's, I think, fairly general knowledge that is worthwhile to take away from there, I would argue. So always worthwhile a look. Our session is running until 3, right? Is that correct? Yeah. Who's sure and who just wants to get out of here? Okay. Cool. Just a brief catch up. Last session we briefly talked about TDD, which I'm supposed to talk about as well, but I skipped this. TDD. What was that? Sure. That's right. Everyone is acquainted, somewhat, ish. Right. Else, I just bring in the cycle. That's my last. Slide I just put in, so because we want to ensure that all of you are on top of things, because that's a quite important principle. So the idea is, who wants to explain the principle? Without a G. Please.
So instead of starting backing from the test, to verify that 60 days. Creating those tasks.
Yeah.
And then we run this once to verify that it failed for the first time.
Good.
And then you start to try to get to a point where you can see all the code.
right? Reiterate or refine until it's the case. If it's the case, think about the next feature and start over, right? So that's the whole process exactly highlighted. So yeah, it's while desirable, oftentimes turns out to be more theoretically constructed. I don't know. I mean, many people, we were preaching it quite strongly in the past, saying that's how way you need to work on things. But in practice, many people don't seem to do it really this way, right? How many of you actually have applied TDD in any project, not in this specific one? Yeah. And what's your impression? What's your experience?
Well, we did it on logical things for the bachelor.
Yeah. Okay.
For that case, it made a lot of sense, but that was just specifically for that part of the system.
Yeah.
Not like totally question development.
Right.
And I feel that if we were to do purely question development, it would just be an overhead. Slow down.
Considerably, right?
Yeah.
Yeah. So that's the impression I get often from people. I'm basically writing a whole, doing at least double the work, right? If not more, because testing is not only, of course, you need to have some sort of thing about the implementation, but there's always a wrapper you need to write around the implementation that makes it incredibly hard. You need to ensure it's safe and so on. So it really depends a bit on your discipline, your area, what you're working in. Richard, do you do test-driven development? Why not?
It's just
Go on.
we don't really have a testable environment when we're playing games.
That's the problem with games. Testing games are a nightmare. In fact, there's hardly any testing game communities, right? To some extent, because they want to sacrifice performance by making the environment testable as well, right?
Yeah.
This is one of the discussions that I follow. So slightly different from information systems, where we're a bit more geared towards testing and more careful about this. Anyway, I'll leave it at this. Enough for you guys. Thank you for your attention. I appreciate it. And I think we see ourselves in 2 weeks anyway, but I would encourage you to remind yourself, well, I send out another message, but also your colleagues show up on the 15th of October. So I have some sort of session afterwards. We're briefly talking about the program as a whole, right? For you to shape the masters, but also give some feedback and so on. And we want to ensure that you're still on track. And we count the number of people showing up, and anyone else is considered having failed the masters. No, not as bad, but we encourage you strongly to show up then. Thank you very much.